hold on one second, I'm sorry. So as it said in the communication, so you can take that challenge exam either Monday, July 14th, Tuesday, July 15th, or Wednesday, July 16th. The testing center opens at 8 a.m. Even though it's open until 6 p.m., it does take it, you are given 1 hour to take the exam, and they will cut off the time to sit at 4:45, and that's what I put in the actual email that I sent to you. So let me just share my screen real quick so you can see what I'm talking about. All right. So this is the email received. So here we are. This is the Calc Challenge link that you got. That's how you ended up here. If somebody forwarded you this link and you hopped on without registering, you won't be able to take the exam either way. So do it the right way, because when you walk into the testing center, you'll be denied. All right. So this is the Zoom link. So welcome aboard. And I wanted to talk to you about some of the resources that you absolutely should connect with. So this is in that original email. If you click this site or you scan the QR code, it will take you here. Hopefully you'll be able to see it. Give me 1 second. Or not. Hold on 1 second. It'll take you here. So this is my not to be famous YouTube channel, and it just houses all of any content that I created over the years related to clinical calculation. But the areas that you should focus on for the challenge exam are the challenge courses. So somebody sent in a message to the chat. By the way, I am not that chat savvy when it comes to delivering content and trying to read chat messages. But yes, this video, when it's recorded, I will post it in the YouTube site, which is this link, okay? But look for those videos that talk about the Calc challenge.
I don't see the YouTube.
Oh, you don't even see it at all?
No.
Hold on 1 second. Let's try this again. Can you see it now?
Yes.
Okay. So when you hit that QR code or you hit that link, it'll take you here. So this is just the channel where I've uploaded videos related to calculations. So it goes over, these are other courses. So these are other courses every semester, not every semester, but every year you'll take an exam for calculations. But I want you to look for those Calc Challenge classes. And this will really help you prepare for the Calc Challenge exam. This is just one way. Also, you can look at the final exam preparation, because the final exams that are given in the actual class are similar to the Calc Challenge exam that you're taking. It's a culmination of everything they learned over the 14-week semester. So this also has videos related to just doing certain things like doing reconstitution or doing IV pump and gravity questions or doing one-factor questions. So these videos are there for you to reference and go look at if you so choose. So let me just reshare. So you're in that email, that link. Also in this email that I sent are links to something called Jeopardy Labs. So Jeopardy Labs is just a program that I use like flashcards. I've created these for the students so you don't have to go and create them yourself. You certainly can do whatever it takes to memorize content that helps you. I'm all on board for that. When you click on these links, it will open up. Unfortunately, it won't show you. Let me just reshare. It'll open up Jeopardy Labs. So when you get to a screen like this, I tell you, select No Teams and hit Start. So what is this? Well, this is just how to memorize abbreviations, because when doctors write orders for medications, they use abbreviations. And if you're taking this class, you're going into nursing, so you need to know the abbreviations. So this is one way to understand and remember the content. So you just click on one of the tiles and it says cup. So what's the abbreviation for cup? It's literally the letter C. So these were built for you just so you can remember and help memorize. You've only got a few weeks to get this all down pat, but you can do it. So GL, what does that mean? class. So that's how you use Jeopardy Labs. Okay. So this is why I'm just showing you this resource. That's why it's in that email. So let me jump back over to here. So there are three Jeopardy Labs created for you to help memorize the content. So one is abbreviations, one is equivalents, and one is military time. You definitely should focus on memorizing the equivalents. And I'll tell you why, because you need to know the equivalents, and I'm going to show you again. I'm sorry, I have to keep jumping around. The equivalents are what you're going to need to do to memorize. Just bear with me. The equivalents are what you're going to need to do to be able to solve the equations in calculations. Hold on one second. I'm sorry, it's just not letting me. So again, equivalents, go to no teams, hit start. So basically it's going to say 1 kilogram equals how many grams? Good, you got to memorize that. Great. 1 teaspoon equals how many milliliters? 5 milliliters. 1 glass equals how many milliliters? 240 milliliters. Why is this important? Because one of the equations you have to be able to solve in calculations is intake and output. And it's all solved in milliliters. So these will help you memorize how to do equivalents in order to enter the information to solve your equations. 1 cup, that's why you need to know the abbreviation. C is cup, equals how many ounces? Well, 1 cup is 8 ounces. And the reason you need to memorize this is because you can't have this information available to you during your exam. Okay, hold on, I got something. All right, good. All right, so that's that. Hold on. Got to keep bouncing around. And then finally, probably the most important thing is right here, you'll see in that email I sent you, access to videos, PowerPoints, and practice sheets. When you click on this, it will take you to something called SharePoint. It's asking me to identify myself. It logged me out, of course, which is good. It's a security response. All right, stand by. So when you access that folder, it will take you to this clinical calculations course. And in here is every PowerPoint that's narrated for you, every PowerPoint that demonstrates how to do everything that you would learn if you took the actual class. Now, my theory is this: if you committed to taking this exam on July 14th, and after today's review, you spend the time reviewing all of these PowerPoints. Let me give you an example. You go into the file, you press play, and it talks about feeding. If you do this and you do the content, you will be successful for taking the exam if you honestly give that 100% to do it. But you got to put in that work. So you have all the PowerPoints, not to mention that you have all the practice sheets, everything you would need to practice starting from week 1, week 2, week 3, week 4, all the way to week 15, 14, to take the class. So you have access to all of this content. I definitely think If you have never done any kind of calculations, you should commit to doing these watching the PowerPoints, doing the practice sheets as if you were taking that 14-week class in the next 2.5, 3 weeks, because I have seen many people be very successful on this exam doing the work. So if you have the ability to commit to that, go for it. That would guarantee you would be very successful. So again, this is weekly practice. And also there's a link to the webinars, which where I showed you. It has all of the same Calc prepinars, Calc, all the summer Calc challenges, winter Calc challenges, all the videos. So when you watch the videos, I encourage you to pause them, try to solve the problems, then watch the video where I do the equation with you. So these are just ways to help hardwire the information and practice, practice, practice. Muscle memory will kick in. Practice, practice, practice. So these are the things I wanted to show you real quick. When it comes to the email you received, the email is jam-packed with everything you need to get started successfully. And then finally, the last part of the email is signing up for the actual test. So if you see right here, it's this testing schedule. And if you are going to sit for the exam, and I assume because you paid, you're going to sit for the exam, you click on this link. Hopefully it'll open. When you click on the link, this will open up here. I have to redo it, I'm sorry. And then you would fill out this testing center submission form with your name. The course is a calculations challenge. There's no course number. You can put 103 or just write clinical calculations. And then you complete this and it gets submitted to the testing center. Okay. So when you do that, you'll get access to, you'll be allowed to sit for that exam. So hopefully that makes sense. And if there's any questions, you can always email me or the nursing office. Is there a deadline to reserve the spot? There's not. I don't think there's a deadline, but I wouldn't wait, because if there's 30 or 50 people that are going to take the test, there's only so many hours in those 3 days. And if it's a time that you need, let's say you have to do it after work, so 4 o'clock. But if 30 people signed up for 4 o'clock on those days, they won't take you. Okay. Yes, you can choose a time. So anywhere starting from 8 a.m. to 4:45 p.m. because we need an hour to take the exam. So now the actual exam, glad you asked, is 20 questions. And each question is worth 5 points. To pass, you need a 75%. Okay. So you need to get 7.5 of them right. So let's talk about that. Let me stop my screen share here. Randy, you said at the bottom it says upload exam. I'm not sure what you mean. I'm sorry. No, if you already submitted your testing request, you don't need to do it again. I know that they gave you the link. Use that link. That's fine too. Somebody raised their hand. I'm sorry. It's not showing me.
Yeah, I'm sorry. I just have a quick question. The link that's on the bottom of that email that we got this morning, it says it's the testing, like, exam submission form. Is that what we do after we finish the exam?
Oh, no. It says testing exam submission form. I'll check the link and I'll resend it if it's incorrect.
Okay, thank you.
No problem. All right. Again, yes, if you already submitted the requested test, you're good. You don't have to keep submitting it. All right. All right. I think I got everybody's questions. Cool. All right. Let me just get out of this. All right. Now, some of you may be LPNs and you are familiar with clinical calculations. Awesome. Love it. But this will just be a new way. If you didn't learn dimensional analysis is the way that we teach clinical calculations. So we use that to teach clinical calculations, dimensional analysis. So you don't have to do it our way. if you've learned it another way. You can do it the way you were taught, but I teach it, and the other professor that teaches this class, we teach dimensional analysis. That's the method we use. So I just wanted to let you know that, because some people ask, well, what if I do it a different way? Well, that's fine. We just need to make sure you're getting the answer right and giving the patient the right med so they don't die. That's pretty much why we teach clinical calculations. All right, so I am going to share my screen. Now, while I do all this, I'm going to close my video because for some reason I lose concentration when I'm staring at myself. So I'm just going to close my video image off. And I'm trying to make this so you can see. All right. All right, so here we are. So this is an example. Well, number one, after you make your appointment, I can put my camera on for a minute. After you make your appointment and you go to attend your test, please make sure you bring ID with you, whether it's a school ID, and if you didn't get a school ID yet, at least a driver's license, because they will not let you take your exam without it. And also make sure you bring a pencil and a basic calculator. So when I say basic calculator, I'm talking about basic. 25 buttons, nothing fancy, okay? Nothing digital. No, you can't use your phone. You can't use your watch calculator. Just a basic 25 button minimum calculator, okay? So you can get it at Staples, you can get it at Walmart. I got them all over the place. All right, so remember, it's a basic non-programmable calculator. No other devices are permitted. They'll make you leave everything in the front of the room. Exam security is very serious. So everything's left in the front of the room, and you will be allowed to take your pencil and your calculator. You don't get to take your equivalent sheet, your abbreviation list. You cannot take any of those items. You have to memorize those things, okay? So after you make your appointment, you're going to bring your ID. You're going to bring your fancy calculator. And then I wanted to review what that looks like. So your exam will tell you exactly what you need to do to pass or how to get credit. So you must show all your work in the space provided on the exam. So what does the exam look like? I'm glad you asked. It kind of looks like this. Each page will have 2 questions on it. And first you'll have your question here. And then right underneath it will be that work area. That's where you show your work. In the work area, show me. Here is where I'll see that you know how to solve the questions that you put. And when you get to your final answer, you only leave the answer here on the answer line. I have seen some weird stuff, but you have to put the answer on the answer line. Okay. And I know it sounds kind of weird. Why is she even saying that? She's weird. It's because people will put answers down here and then wonder why they didn't get the points, because I have to look through all of the work that they did to find the little answer in the corner. That's not how this works. Okay. You put the answer, one answer on the answer line. Okay. So you show me your work in the work area. Show me your work. And then when you get your final answer, you're going to put it right on the answer line. Okay. It's pretty much what that means. All right. So you only write one answer on the answer line. Okay. Your answers must include the correct unit of measure. So a unit of measure is how we're going to administer something. So I'm going to administer a tablet. So a tablet is a unit of measure. I'm going to administer a capsule. That's a unit of measure. I'm going to administer milliliters or milligrams or ounces or teaspoons or something in pounds, or maybe a question needs time. The unit of measure will be hours or minutes. So the unit of measure matters for your questions. If you give me a number with no unit of measure, it could lead to a med error. So if you give me an answer, let's say the answer for this was, how many tablets will you give your patient? And you just write 4. I have to mark it wrong and you lose 5 points. For what? 4 turtles? 4 unicorns? 4 milliliters, 4 ounces, 4 tablets, 4 stars. So the unit of measure matters. All right. Anything in military time or anything that requires time, we answer in military time. If you don't work clinically, all of our medication administration records, how we dispense our meds to our patients, is all in military time. So I encourage you now, as you enter nursing school, to change all your cell phones and watches to military time. Because you have to know how to read military time. And then finally, you have to learn how to round the medications according to RCC. So we're going to go over that to get full points. If you make an error with rounding, you only lose 1 point. Out of 5 points, you would only lose 1. And I'll talk about that a little bit. And I'll talk about the 0 rules and about score tablets and what you don't round. So I already talked about the YouTube site. I already talked about the Jeopardy labs. I already talked about the access and then the testing center form. So we got pretty far. We're not doing too bad for 25 minutes. Okay, good. Any questions so far? I'm sure you guys have a million things you want to ask. Can we have blank sheets of paper? No, you work, you're going to show all your work on the exam. The exam is on paper.
How long does it take for us to get our results back?
You should have results if I pick them up by, because everybody takes the exam, they have until Wednesday, probably by Friday. But you will only know that you passed or failed. Yeah, Melissa, if the link I sent is the wrong link, I'll resend it for the testing center, okay? No worries. So again, there's 20 questions, 5 points each. You need a 75 to pass. Is it doable? Yes, totally doable. I see it every semester. And what about the worst case scenario? What if you don't pass? Okay, you gave it a good college try. I mean, come on, we're cramming a lot of content in a short period of time. I would totally go for this too. I would totally go for the effort. But if you don't pass, the worst case scenario, you have to sit with me for a semester. I'm sorry, I know. Okay, I'm sorry. But the worst case scenario is you just take the class, okay? It's a 1 credit class. It meets for 50 minutes each week. I do it on Thursdays, or you can do it online. But either way, it's 14 weeks where you can prepare. All right? So without further ado. All right. Real quick. This is a very simple type of question. I want you to read this question and tell me how you would answer this question. And you could put it in the chat. You could put it to me directly, so you don't have to put it to everybody. What do you think the answer to this would be? Okay, I see, yep, multiply 0.354 by 4, okay? So what would the answer be? All right, I'm getting some answers, okay, good. Okay, yep, I'm seeing lots of answers, but I'm also seeing a lot of numbers and no units of measure, okay? So remember, keep that in mind. Okay, good. So you're right. If you said, well, basically they want to know the total amount of med the patient got for the day. So the patient's getting 0.345 milligrams of some fancy drug, and we gave it to them 4 times by injection. So you're correct. I would put into my calculator 0.345 times 4, and my calculator will tell me what? 1.38 milligrams for the whole day. So now here's where the rounding rules come in. And we're going to talk about it in detail. This would be marked as a -1 point. Why, Professor? Why are you so mean? because it's one of the rounding rules. Any number that falls between the number 1 and the number 10, we always round to the hundredths. I mean, to the tenths place. I'm sorry. I'm jumping ahead of myself. We round to the tenths because number 1 falls between 1 and 10. So I need to decide, is my answer going to be 1.3 or 1.4? So who makes that decision? Well, it's this guy right here. So this number here, the number 8, is greater than 5. 5 is the midway point. So anything that's 5 and up, I round this number up. So for those of you who did put 1.4 milligrams, you would get all 5 points. So here's a little strategy. And I'll deny I said it. But if you're not sure what to do when it comes to rounding, okay, leave it. Take the hit and lose the 1 point instead of changing it and making it something wrong. Or at least if you change it and make the error and show me your work, I can see what you did and make a decision if you're going to lose 5 points or just 1 point. Okay, so I just wanted to introduce that to you. So now, knowing what you know, what's the answer to this question? Okay. Okay. I love when people write, no, this, question mark that. Oh my God. I see you, Faye. I know what you're doing, okay? Jamila, question mark. Jamila got the question mark there. You would be shocked what I get on my exams, okay? No, that's perfect, Hill. It's great. I get all kinds of stuff. That's why I talk about it. So yeah, so you're going to do 3.35 milligrams, and they got it 3 times. So when you do that, your answer on your calculator will be 10.05. But what are my rounding rules? The rounding rules, any number greater than 10, I have to round to a whole number. 10 and up, I have to round to a whole number. So I look to the right because I saw somebody wrote 10.1. You look to the right. I look to the immediate right, and it's 0. So I don't move this number at all. So the answer is 10 milligrams. But like I said, if you're not sure, go for it, but show me your work so I know where you're at, okay? So that was just a little introduction. And you may see a problem like this on that exam. Did I blink twice? Okay, good. All right. So be mindful of that. So let's talk about rounding real quick. I just gotta find it. Okay. So yeah, the rounding rules. Well, the good news is on the front page of your exam are the directions with the rounding rules that I showed you earlier. So you actually can reference the rounding rules during the test. That's the only thing that's available to you. But I do find that people get confused anyway, even though it's easily accessible. So let's look at this right here. What are the actual rounding rules? Well, number 1, you never round until you get to the very end of the problem. You never round during setting up your questions. You always round at the very end of the problem. So at the very end of your problem, if your number that you get on your calculator is less than 1, and you will know it's less than 1 because it'll be 0. Whatever, 2, 3, 4, let's say, on your calculator. Let's say your calculator ends up with 0.2345. What is the rule to round this number? Well, if it's less than 1, we round to the hundredths, and that's this number. So what do? I look to the right. If it's 5 and up, I round this up. If it's not, I leave it. So what's my answer? The answer would be 0.23. Okay, right. You got it, Kirby. So that's what that means, less than 1. If there's a 0 in front of it, 0.23. Now, speaking of the 0 in front of it, why do you think it's important to write this with a 0 in front of it? Why would I leave this 0, 0.23 in front of it? Let's say it was 0.23 milligrams of a cardiac medication. Why do you think it's important to leave that 0 there? This is the rule of 0. So it doesn't get confused for 23 milligrams. That's right, to make it clear. Could you imagine if you worked neonatal intensive care and the infant baby needed 0.23 milligrams of a cardiac med because they have a congenital defect? But the doctor doesn't put the 0, he writes 0.23 milligrams. And pharmacy picks it up as 23 milligrams. And then nobody verifies and checks it against the weight. And then the nurse accidentally administers 23 milligrams of a cardiac med. And something happens to the patient. So that's why we have these rules of zeros with rounding. So yes, when it's less than 1, we always put that 0 before. So what do you think the rounding rules are for something as a whole number? What if the patient did need 23 milligrams of a med, but the doctor wrote it 23.0? What could happen there? The same thing. What if it was picked up as 230 milligrams? Right, Jay. It could be confused for 230 milligrams. So can you say I killed the patient? Yeah. So these are the rules of zeros. We never have a trailing 0, and we always have 1 before the decimal when it's less than 1. All right, good. So any number between 1 and 10. So let's say it's 3.689 is your final answer on your calculations. This number 3 is between numbers 1 and 10. So 3.689, how do I round this number? 3.689 milliliters, let's say. Remember, 1 to 10, we round to the tenths. So I look to the right, it's 5 and up, so I round this one up. The answer would be what? That's right, 3.7 what? Oranges? Yes, milliliters. 3.7 milliliters. That's it. That's the unit of measure. That's what you can't forget. All right, cool. And then any number greater than 10. So if it was 10.1, what would the answer be? 10. Because you round to the whole number. That's right. What if it was 10.5? What's the answer? 11. There you got it. Class dismissed. No, okay. All right. So there's some practice. So I'm going to have you solve this one right here for me real quick. All right, good, Deanna, good, Yael, yeah, good, Kirby, you got it. So yeah, so this number is less than 1. Any number less than 1, we round to the hundredths. So I look immediately to the right, it's 3, so that's not 5 and up, so my answer will be 0.12, and don't forget the unit of measure, micrograms. That's it. What about this number? What's my answer for this one? You got it. Yes. It's any number greater than 10, we round to the whole number. I look to the right, it's 5 and up. So the answer is 56, and it's what? Milliliters. It matters. All right. That was your rounding rules. Beautiful. All right, that's pretty cool. So I think that's pretty cut and dry. I can't go into how to change a fraction, but you need to understand how to change fractions and work them into problems. We work with fractions with dimensional analysis. All right. So this is not the class where I teach you how to do math fractions. You should know how to do it, how to convert them. I just wanted to bring that to your attention because you need to know how to do it for the intake and output. All right. All right. I'm just trying to find my, oops, nope, wrong one. All right. All right, so we did rounding. So examples of unit of measure we talked about quickly. It's either milliliters, liters, milligrams, tablets, capsules, ounces, teaspoons, tablespoons, micrograms. It could be kilograms, it could be pounds. These are all examples of units of measure. And then you have to remember the conversions, the equivalents. So just out of curiosity, does anybody know how many milliliters are in 1 liter of fluid? Okay, Kirby's there. So one of the things you would have to memorize is that 1 liter is equal to 1,000 milliliters. Oops. What about how many milliliters are in 1 glass? Because you need to know GL is glass. Right. So 1 glass is 240 milliliters. And these are all the practice sheets that are available to you. How many milliliters are in a cup? 240. Yeah. So you're like, why do I need to know this? Because when your patient is taking in fluids and you ask them, hey, what did you drink for breakfast? They'll say, I had a cup of coffee and I had a cup of juice. Well, you can't write on the intake and output a cup of coffee and a cup of juice. The doctor needs to know how many milliliters have gone in so we can compare it to how many milliliters have come out. So we always do our intake and output in milliliters. But that's why you have to memorize these conversions. How about 1 ounce equals how many milliliters? Yeah, 1 ounce is 30 milliliters because maybe you gave your patients 2 ounces of a medication. That counts. If it's a liquid going in the body, it counts for intake and output. All right, cool. So let's talk about intake and output. So I really encourage you to look at those PowerPoints in that Calc Challenge review. All the PowerPoints are there, but for a quick review, intake is whatever the patient gets into their body that's in liquid form, or foods that melt to liquid form at room temperature. So what's included in intake? Anybody want to tell me? Give me some ideas. What's going on? I'll start. IV solutions. Yes, Justin. Sometimes patients receive intravenous medication or fluids, and it counts as intake. We're putting it into their body. So we have to calculate that into their intake. Anything they drink, coffee, juice, anything they drink, ice cream that melts at room temperature, Jell-O that melts at room temperature. Okay, this all counts as intake. So anything taken in by mouth that is liquid or melts at room temperature counts. Some patients can't eat and they have a tube in their belly. And what do we put into that tube that goes into their stomach is a liquid, a feeding. And that counts, and that has to be calculated into milliliters. So these are all things that are part of intake. What's part of output? Think about, yes, urine. If the patient urinates, we got to measure it if we have to monitor their intake and output, and we have to measure it in milliliters. Why is it important? Well, let's say you gave your patient throw up, go EIL, yes. Yes, and it may not say throw up, and I'm glad you actually wrote that. It might say vomit, emesis. Those terms mean throw up. Diarrhea, yes. Diarrhea is liquid stool. It counts as output. Dialysis, what you put in, and you have to measure depending on the type of dialysis, if it's peritoneal or what are you drawing off. We measure in and out. Yes. So these are all things. So when we talk about output, we're talking about urine. We're talking about vomit, emesis. We're talking about wound drainage, and diarrhea. These are all things that can be measured in milliliters that we must include in output. So here's an example of a question you may come across. First, let's start with, what do you think is included in input in this question? You can say it, you don't have to type it. Just input.
The IV and fluids.
antibiotics.
Half a liter, 100 milliliters of antibiotics. What else went in this patient that you need to calculate?
Milk, broth, eggs, toast.
Half a cup of milk, 2/3 cup broth. Do we count the eggs?
No.
No, it's not liquid.
Coffee.
Coffee, yes. That's all in. The eggs, the toast, that's solid. 4 ounces of chicken? No, we don't count that. That's solid, only liquids. So what's included in output? Well, the patient went at 7 a.m., 300 milliliters of urine. Then they went again at 11. Then they went again at 4. Then they vomited after all that delicious food. And then they had an episode of diarrhea. So when you're doing intake and output, it's 2 numbers. You need to calculate input and give me an answer, and output, and then give me an answer. So this question, I always start with the output because it's easy. What happened? That was weird. Can you still hear me? Okay, I always start with output because it's just easier. So the patient urinated 300 milliliters, then 450 milliliters. You see how I cross off? I don't lose points for nobody. 675 milliliters, I cross it off. Then they vomited, that counts, 100 milliliters. And then they had diarrhea, which is liquid stool, 320 milliliters. So what's my total output that I would put on my answer sheet? I'm going to calculate because I don't remember. $18.45 milliliters. So now input. Now this is where knowing your conversions matter and knowing how to do fractions. And we're going to talk about how to do this in the next section. But you have to know how many milliliters are in 1.5 cups milk. How many milliliters? How many milliliters are in 2/3 cup broth? How many milliliters are 2 1/4 cups of coffee? So you see how challenging it could be. You have to not forget that there's a half a liter is how many milliliters, and 100 milliliters of antibiotic, which would be 100 milliliters. So you have to know how to solve all of these using fractions and dimensional analysis. Okay, and it's not as terrifying as you think. But you correctly identified what you would calculate in intake and output. Now, if I was a betting kind of teacher, I'd say you might see one question on this exam related to intake and output. Yeah, you might. Another thing I want to point out to you real quick about intake and output. When you see the patient has had an IV running at 100 milliliters an hour, and then they ask you to do the intake and output for a 12-hour shift, what would you write for this one as intake? Think about it.
Hi, Prof. Sorry, I'm a little confused here. Are we saying solids are not inputs?
Not for liquid, no.
Okay, so are we focusing on liquid inputs?
Only liquids. Anything that melts at room temperature or is a liquid counts for intake and output.
Thank you.
Sure. What would you write? The IV has been running at 100 milliliters an hour, and they want to know over a 12-hour shift. I bring this up because I see this error the most. If they're getting 100 milliliters every hour and you're calculating for a 12-hour shift, no, that's right. It's 1,200 milliliters just for this part. 1.5 cups coffee. All right, so don't forget your IV in when you have a question like this, pay attention. Okay. So now I want to show you how to do all of this figuring out using dimensional analysis. So if you look here, let's say the patient drank 1.5 cups of coffee, and you're doing intake and output, and you have to convert it to milliliters. Dimensional analysis just needs to know how you're going to set it up in a fraction. So we call it given wanted unit path conversion needed. So what's given to us? Well, they tell us that the patient had 1.5 cups of coffee. Okay. What is wanted? Well, we need to know how many milliliters. That's how we solve intake and output. So how do we get there? We have to convert the cups to milliliters. So I need to know how many milliliters are in a cup. So 1 cup is how many milliliters? 240 milliliters. Okay. So where do I start? Well, I always start with what they gave me, and that's 1.5 cups. So you need to know, oops, sorry. How do I change 1.5 to a decimal? Or how do I write it? Does that look about right? So the patient had 1.5 cups. Now I want you to notice I'm starting to set up my fractions now. And I need to solve for what? What's my wanted? Milliliters. Okay? Don't get excited yet. Just watch the process. So in order to get rid of this word cup and get to milliliter, I need to put something here and here. And it's my conversion. So to cross off the cups, I need to write 1 cup is equal to 240 milliliters. When I write the cup on the top and the bottom, which is the numerator and denominator, I can cross it off. And then I'm left with milliliters. Okay, my screen is not refreshing. Why? There it is. Okay. So when I do this and I cross off what I don't need and I just keep what I need, I can solve my equations. And this is why you need to know the conversions. So 1.5 times 240 is what? You got it. 360. It's already rounded. So what am I going to write as my answer to this question? 360 milliliters. So now, this patient for breakfast drank 1.5 cups of coffee. And we said that's 360 milliliters. And they had an IV going at 1,200 milliliters an hour. So this is part of our intake. So you would have to go through each of these, 1.5 pints of water. This doesn't count. You have to see what they had for in and then figure out for input and figure out for output. But you have to use dimensional analysis. Well, you don't have to, but it's a good way to do it. So let's do 1.25 pints. 1 2/5 pint is what's given to me. What I need is milliliters. How do I get there? I got to get pints to milliliters. So what's my conversion? 1 pint equals, does anybody know? $480 milliliters. That's a quart. 1 pint is 480. A quart is 960. You'll learn it. All right. So how do I set it up? Well, first I got to make this a decimal. So 1 2/5 pint. So I'm going to only show once how to do a fraction. So if you want to make this fraction into a decimal, you first you got to shorten the fraction. So 5 times 1 is 5, plus 2 is 7/5, and then 5 divided into 7 is what? All right, so there's a start. I don't know why you guys, my screen is not keeping up to date. So you can make your fraction into a decimal. 1.4 pint, and 1 pint is 480 milliliters. Cross off my pints. I have my milliliters because I need milliliters as my answer. So 1.4 times 480 is 672. That's correct, Kirby. So the answer is 672 milliliters. So that's how you use dimensional analysis and the conversions. And that's just for the intake and output that I want to show you real quick. All right, so it's basically a series of fractions when it comes to intake and output, but so is dimensional analysis, okay? So let's do one more with ounces to milliliters. So what's given to us? Well, what they gave us was 8 ounces. We need milliliters. And the path is ounces to milliliters. So what are my conversions? I know that 1 ounce is equal to 30 milliliters. So how do I start my problem? I start with the given. 8 ounces, and I put it over 1. So I know I want milliliters over 1. So for those of you who don't remember in a fraction, that's why I said I'm not teaching math. The top number is the numerator, the bottom is the denominator. When we solve for a unit of measure, we always need to in the numerator position. So that's why I always do it like this. So now the idea is I need only milliliters as my answer. So I have to get rid of ounces. So how do I get rid of the ounces? I use the conversions. So how do I get rid of ounces? How do I put the conversion in this problem? Where do I put the 1 ounce? In the numerator or the denominator? Right, in the denominator. 1 ounce is 30 milliliters. When I do it like this, I can cross off the ounces diagonally, and I'm left with only milliliters. Everything else is crossed off. So when I do that, now I just multiply across the top and bottom. So across the bottom is 1 times 1 is 1, and 8 times 30 is, I'll even check, 240. And then 1 divided into 240. So my answer is 8 ounces to milliliters is 240 milliliters. That's dimensional analysis. That is it. So what do you need to show me on your worksheet? I just need this. You don't have to do all this. You should do this until you got it mastered. But this is what I want to see, your setup and your calculation.
So we won't get a point if we just put 8 ounces, like 8 times 30.
If you show me 8 times 30 and the answer, yeah, I'll give you your points. I got to see something. So what about this conversion? Pounds to kilograms. So what's given to me? The patient weighs 115 pounds. What do I need? Medication doses that are based on weight are always kilograms. So I need to convert pounds to kilograms. So what's the conversion? Does anybody know?
Two pounds.
Yes, 1 kilogram is equal to 2.2 pounds. So how do I get, I always start with my given in my numerator, 115 pounds. And what do I need? I need kilograms. That's my goal, my wanted. So how do I get there? I have to get rid of pounds. So how do I get rid of pounds? I'm going to use my conversion. So I'm going to put 2.2 pounds down here so I can cross off. Then I'm going to put 1 kilogram here. And guess what? Now I have only kilograms. So now it's just math. So 1 times 2.2 is 2.2. And 115 times 1 is 115. And then I have to divide 115 divided by 2.2. That's why you should use a calculator. So then my calculator will give me an answer of 5.2272727. What's my answer on my answer line? All right, Kirby, you definitely reversed your fraction. Right, the answer is 52. So 115 pounds is 52 kilograms, because any number greater than 10, we round to the whole number. We look to the right. It is not 5 and up, so we keep it the same. The answer is 52 kilograms. And that, my friends, is how you do dimensional analysis. So now let's talk about what you're going to see and what you got to prepare for. So I'm going to start with the easiest stuff first. Although all of this it's all, you have to just practice. That's the way you get to understand the information. Okay. I just gotta find it. Some patients can't drink or eat by mouth. Maybe they've had a stroke. Maybe they've had surgery that prevents them from eating anything by their mouth. So what happens is we surgically implant a tube in their stomach, or we put a tube in their nose that goes down into their stomach. Either way, they can't swallow without either choking or something happening. So this is called enteral feeding. It's a way to feed the patient and give them hydration and nutrition and calories when they can't eat food, all right, or drink liquids. Okay, so this is a problem you're going to come across. Thank you. Yes, Yael. Good. So this is the type of problem you're going to be asked. All right. The doctor orders half strength. So why would the doctor order half strength of something? Well, when patients have these new tubes, their stomachs are not always ready to tolerate the richness of this formula. If you even think about formula for a newborn, sometimes the formulas are so rich, we have to switch the formulas up. But for older patients that have these tubes, or any patient, if they can't tolerate full strength formula, we dilute it with water, just so their stomach can learn to tolerate how to process this food and fluid, okay? So you're only going to ever see half strength. So you just need to know that you will be asked either how much water you're going to add to the feeding to dilute it, or you're going to be asked what is the total amount the patient received. So if you look at this question, it clearly says the doctor ordered half strength. You go to the pantry and there's a can with 250 milliliters of formula in it. See there, 250 milliliters. How much water will the nurse add to the can to dilute it to half strength? So now a lot of the students were like, well, how can you add water to that can? There's not enough room. I know. In practice, we add everything to a separate bag. I just wanted to bring that up because people really fixate on that instead of the process of diluting it. The easiest way to do this is, trust me, this way. If you have a can of 250 milliliters and you need to make it half strength, you need to add equal parts water. So this question said, how much water will the nurse add to the can to make the half strength dilution ordered by the doctor? What is the answer you will put on the answer line? You got it correct, Yael. Correct. 250 milliliters. That's how much water. If you add equal parts of water to the feeding, it dilutes it by half. That's the answer. So you're like, wait, that's just too easy, Professor K. What? Absolutely too easy. Well, what if it said it this way? What do you think the answer to this one is? The doctor says 50% strength. And you go in the pantry and the can is 350 milliliters in it. How much water will you add to make it 50% strength? I can see my overthinkers already. If there's 350 milliliters in there, you go into the pantry and the doctor needs 50% strength, which is half strength. And the formula has 350 milliliters. Let's say it's Glucerna or Boost. Yes, Tahila. If it's already, and the doctor wants 50%, which is also the same as half strength, you add equal parts water. Don't get confused when terminology changes. 350 milliliters of water is what you're going to add. Oh, there you go, Faye. You got it now. Right. So you're going to add equal parts water. Just because the question said 50% instead of half strength, you guys get confused. See, when we teach and prepare you guys, we're preparing you to sit for a national exam, right? We don't know how they're going to ask you the question. So we're always going to try to interject a couple things. Is there ever a case where you don't use the full can or always dilute the full can? Yes, sometimes the doctors just go right in, give them the full strength formula, and you'll just administer it at a certain rate. Let's say how fast you have to give it. Do we write 250 milliliters of water? No. If I say how much water will you add in the question, all you're going to write on the answer line is 250 milliliters, or in this case, 350 milliliters. If the question asks you how much water, then that's what you would just write the number and the unit of measure. But I mean, I have people that still write water. That's fine too. But what if it didn't ask you water and you wrote water, then you're wrong. So I would just write the number. So now let's see. Do you really think I'm going to ask you a question about feeding and in milliliters? No, I'm going to ask you to convert something into milliliters because remember, feeding is part of intake. So what if you go in and there's a 4-ounce can in the pantry? I go in and the doctor wants half strength Nepro and it's in a 4-ounce can. So, okay, Professor K, I got to do half strength. I'm going to add 4 ounces of water. So let's say on the exam, you write 4 ounces of water. It's wrong. What is it asking you? Even if it doesn't say it, you have to answer in milliliters. So what do? Given, wanted, 1 ounce, 30 milliliters. Cross off my ounces. I have milliliters. 4 times 30 is? That's the correct answer. Got it? Good, Tahila. What if I asked you, what's the total amount the patient will receive for this feeding? What if the question didn't say how much water? What if the question said, what is the total amount the patient will receive from this feeding? That's correct, Tahila. What do you guys think? 4 ounces, 4 ounces. You can do 4 ounces and 4 ounces is 8 ounces. Or you can just do 120 plus 120 is 240 milliliters. So that's just feeding. Let me find the total volume. All right, do this one. And then we got to move on. My goodness. Stand by. Go ahead and do this one. Meaning, what's the total amount the patient will receive? So this does have two questions in it. Like I said, on the exam, it will ask you one or the other, but I'm just going to get a 2-for-1 here. Okay, good. I'm seeing the right answers. All right, I think you guys got it. So the doctor orders 50% strength. That means just half. That means we have to dilute the feeding. You go into the pantry, and this special formula has 6 ounces in it. If I have to make it half strength, I have to add 6 ounces of water, right? So basically, how much water am I going to add to dilute it? So it's 6 ounces, but I have to solve for milliliters. So 6 ounces times 1 ounce, 30 milliliters equals how many milliliters? Cross off my ounces, 6 times 30 is 180. So for the first part, how much water is 180 milliliters? And then what is the total amount the patient will get from this feeding? Well, 180 plus 180 is 360. You got it, yeah, good. All right, but again, on the exam, if you were to see a question like this, it'll ask you one or the other. You have to pay attention because details matter, okay? Talking about, we're gonna be nurses here. We ain't playing around. All right, so that's feeding. The next thing I want to talk to you about is solving for insulin. Now, there is a whole class on insulin when it comes to mixing insulin. And if you take 118 fundamentals with me or Professor McMorrow, in clinical, we teach you how to mix insulin. Literally, we give you syringes and we teach you how to mix insulin. All right. But there are types of orders that doctors write for insulins that you need to know how to solve for. So here's an example of a doctor's order. There's 2 parts. There's the original order, and then there's a coverage order. So the original order. And now insulin is a hormone that patients who have blood sugar issues, whether it's from diabetes or from certain medications they're taking, whatever the reason is, insulin is used to lower the blood sugar level in a patient's body. Perfect. Okay. So it's a hormone generated by the pancreas. So for whatever reason, the patient's not generating enough insulin to lower the blood sugar. So we have to give them insulin to help lower the blood sugar. So the first part is the standard order. The doctor will say, I want you to give a certain amount of insulin N, 4 units, mixed with insulin R, 4 units, AC meals. So AC means what? Does anybody know? It's okay. It means,
Meals.
yeah, it means give before they eat. All right. So we got to know the feeding schedule of our patients. So there's a lot of detail that goes into it. I just want you to know that this is going to be part of your questions. So the doctor says he has ordered, give the patient 4 units of N mixed with 4 of R. And they want to know what's the total amount of insulin the patient will get before lunch. Okay. Well, we know he's going to get 4 units of N and 4 units of R. But then we see there's another part of the order. The doctor also says, that's great, but I want you to do a blood sugar test. I want you to prick their finger and check their blood sugar level. And whatever level you get, you have to figure out if they need more insulin. So at 12 o'clock, the nurse goes in, and you prick the finger and it's 149. You have to look here to see if the patient needs more insulin. So based on this blood sugar of 149, will the patient get more insulin?
No.
No. Why? because if it's less than 150, no additional insulin. So what is the total amount of insulin the patient will get before lunch?
8
8 what?
units.
8 units. Yes, because they still had to get the 4 of the N, 4 of the R, and just no additional based on that blood sugar. So 4 plus 4 is 8, and insulin is only given in units. So the answer to this is 8 units. I am not losing 5 points on this question, people, right? I am not losing 5 points on this one. And I'm not losing 5 points on half strength feeding. That's 10 points right there. Come on, you can do this. So let's try this one. I'm going to give you a minute, not even a minute, 30 seconds to solve. You can do it. All right, so I'm seeing some answers coming in. Let's do this. Yes, perfect. You got it. Class dismissed. Jay, I'm going to email you what, right, please? What? You're going to email it to us? What? Jay, you said you're going to email it to us. What am I going to email? Oh, this video. No, the videos are too large. I'm going to post it in the YouTube page. Yeah, they won't let the emails, the videos are too large for email. So that's the only reason I created the YouTube page, because I can't email the videos. I can't even store them in D2L. All right, so yeah, let's do this problem. So the doctor said, hey, your patient's diabetic. He needs to get this insulin before meals. He needs 12 units of N, 8 units of R. That's the order. All right, 12 units of N, 8 units of R. Beautiful. But then he says, wait. I need you to check his blood sugar before you give it. And you go in at 7 a.m., which is before breakfast, and his blood sugar is 348. Number one, ruh-roh, that's high. Number two, I got to figure out if he needs additional insulin. Where does 348 fall? Right here. So what am I going to give? Oh, I'm going to give another 10 units. So if you said 30, you're right. The total amount of insulin the patient will get before breakfast is 30 units. Now you notice it didn't say what's the total amount of insulin in units, because you need to know that if the order says 12 units, that's the unit of measure you have to include. If you just put 30, it's wrong. 30 what? 30 flowers for Professor K? No, 30 units. All right, so that is insulin. I'll give you one more because you're feeling fancy. Let me see here. All right, here's one more. Let's do it. All right, 30 what? $30 what, Randy? That's right. Yeah. Don't you lose points for one. Oh, check your math. Check your math. Right on. All right. I'm not losing 5 points on this question. No way. What do we got going on? The doctor says give 13 units of N, give 11 units of R before meals and HS at bedtime. And it's 2100. And the sugar was 202. So there's two parts of this order. The original order, 13 units of N, 11 units of R. Finger stick was 202. Where does 202 fall? Right there. So I'm going to give another 6 units. So what's my total? 30 units. I don't want to mark it wrong. Do the math. Triple check it. Because when you're giving meds, this is not where you want to make your mistake. Okay? All right. So that's insulin. So now you've already learned how to do feedings and insulin, intake and output. That's like 15 points right there. I'm feeling good. All right. Because you might see these on an exam. I'd be prepared for this. All right, good. Let me go to All right, let's talk about capsules and so here's another one. That's another 5. Gosh, that's 5, 10, 15. That's 20 points right there. If you could figure this one out without making a rounding error, which is only 1 point. And now let's talk about tablets. So as nurses, you're going to be administering medications. Probably 90% of your shift will be medication administration. All right, I'm exaggerating, but I go for the drama. I like it. So how do we solve for these equations? Now, in your everyday life, you go and pick up your Tylenol from the pharmacy. You look at the bottle and it says, oh, I can take 2 Tylenol. But you don't really think about strength and dose and how many. You just know kind of automatically. You can't do that when you're practicing in nursing. These patients are getting medications for their hearts, for other organs or illnesses or disease processes or chemo, or we have to be very precise and exact. And we can't, otherwise we're making medication errors. So we have to look for things that we have to look for doctor's orders and then what is available to us that we're going to solve for. So I want you to look at this one equation. And here I have a picture of a tablet. And if you notice, this tablet has a little marking, indentation, and that's called a scoring mark. And basically that means I can split this tablet in half if I needed to. I can give the whole pill, or I can give a whole and a half of the pill, or I can just give a half of the pill. But guess what? I have to figure out what I'm going to give. So I'm going to show you how to do dimensional analysis just for tablets. So first thing we have to find out is, what did the doctor order? How do I know what was ordered in this question? What is it? Which one is the order?
.25.
Right, it says prescribed. It'll say healthcare provider ordered. Doctor says administer. It'll say those words: prepare, ordered, prescribed. Sorry, I don't know why this is blipping out here. It'll say those things: prescribed, ordered, administer. Those are the words you have to look for. This is our starting point. That's why it's important to be able to identify what is written by the doctor or healthcare provider. So I'm going to start with 0.25 milligrams, and I'm going to put it over 1. So numerator, denominator. Perfect. What is my wanted? In this question, what do I want? What am I going to give? What do I want? What am I solving for? I need to know how many tablets to give the patient. So my wanted is tablets. So when I go and I check what the pharmacy delivers, they deliver something that's not in milligrams, it's in micrograms. So the bottle they sent me from the pharmacy will say 500 micrograms for every 1 tablet, and it's scored. So how do I use that in my problem? How do I get rid of milligrams in this problem? I need to know a conversion, don't I? I need to know that 1 milligram is equal to 1,000 micrograms. And that's part of your conversions that you have to memorize. Okay? So to get rid of milligrams, I have to use the conversion. So when I do that, I can cross off the milligrams. Awesome. But now how do I get rid of micrograms? because I need to know tablets. What do I use? I use what's available. The bottle says every 1 tablet is 500 micrograms. When I do that, I can cross off the micrograms and I'm left with just tablets as my unit of measure. So now it's math. So 1 times 500 is 500. And 0.25 times 1,000 is 0.25 times 1,000 is 250. In my calculator, I put 250 divided by 500, and my calculator will say 0.5. So what is my answer? How many tablets will I give my patient? And Kirby said 0.5 tablets. And so did, I saw Safida, I don't know if I'm saying your name right. Don't forget the 0 before the 0.5. If you write 0.5 tablets, you're going to lose a point because you can make an error and mistake that for 5. Don't forget it's 0.5. You can also write this as a half a tablet like this. Okay? Good. Dahila, don't forget 0.5 tablets. What about this one? I'm going to give you a second to solve. Do this. The prescriber orders 475 milligrams over 1. How many tablets will you give? So I'm solving for tablets over 1. So I got to get rid of milligrams and get to tablets. So I got what he ordered. So how do I get rid of the word milligrams? Well, pharmacy delivered me a bottle that says for every 350 milligram tablet, there's 1 tablet has 350 milligrams in it. And it's scored. And this is what it's scored in. So remember, I can only break this in half if I needed to. So Kirby, Talisha, pay attention, right? So if I can only break this in half, I got to think about it. So let's do it. I cross off my milligrams and I have exactly what I need tablets. 1 times 350 is 350. 475 times 1 is 475. When I put 475 divided by 350 in my calculator, it will say 1.357. So if I follow my RCC rounding rules, hey, it is 1.4, sorry, 1.4. Oh, that looks terrible. Hold on. It does come out to 1.4. But can I break this tablet into 1.4? I have a decision to make, don't I? I have to think, am I going to give 1 tablet? Or am I going to give 1.5 tablets? So do you think 1.4 is closer to 1 whole tablet or closer to 1.5 tablets? And this is where that nursing critical thinking comes in. It's closer to 1.5. Think about it, Yael. Think about it, Randy. Is 1.4 closer to 1.5 or 1? Think about it. It's okay. I don't expect you guys to have this knowledge. That's why I'm sharing it with you right now. 1.4 is closer to 1.5. I can't break this into a quarter or into 0.4. I have to either give them 1 whole 1, 1.5 1. So that's where that critical thinking comes in. So the answer would be 1.5. So what if you did put 1.4 tablets on the exam? Well, if I saw your setup, I would only subtract 1 point as a rounding error. That's why showing your work is so important. Because if you just put 1.4 and no work, I'll be like, I have no idea how they got there. No, wrong. Because it's not really 1.4. You can't give it. Okay. So tablets can also come in quarters. So if you look at this picture, this tablet can be broken in half. Or I can literally just break it and give a little quarter of this tablet. Or I can give 3/4 of the tablet. So solve for this one. All right. So quarter tablet, good. So let's do this one together, okay? So let's start with the same thing. What did the doctor order? He ordered 50 milligrams. Great. What do you have available? Well, I have a bottle that says every scored tablet has 250 milligrams. And that's perfect because I'm solving for tablets. So I'm going to cross off my milligrams because I can cross off diagonally. That's why I set it up this way. And I have tablets. That's what I need. So 1 times 250 is 250 and 50 times 1 is 50. So in my calculator, I'm going to type in 50 divided by 250 and it will give me on my calculator 0.2. How many tablets will you administer? So let's think about this. This tablet can only be broken into quarters. I can give a whole tablet. I can give a half a tablet. I can give a quarter of a tablet. I can give 3/4 of a tablet. So what am I going to give if my calculation comes to 0.2? How much and how many tablets am I given? If I can only give the smallest amount is 0.25, that's what I'm going to give the patient. I'm going to break this off and give them this little chip of a tablet, 0.25 tablets, or some of you did right, a quarter tablet, and that is correct. Okay, so I want to show you good. Yes, that's just tablets. All right. Now we have something called capsules. We have capsules that look like this. We have gel capsules that look like this. So the one thing you have to remember about capsules is I cannot split these in half or break them up. Now, if you work clinically and in your facility, you break these bad boys open and pour it in liquid to give through a feeding tube, I don't want to hear it. That's not what we're doing the RCC way, and that is not the proper way to do it for the NCLEX. So the thing I want you to remember when it comes to capsules is that it's always a whole number. You're either going to give 1 whole capsule, 2 whole capsules, 3, 4, 5 capsules, or gel capsules, or whatever it is. So knowing what you know, we're going to solve. Well, let me let you try to solve this one. So I'm going to give you a little hand because you might not all know the conversions just yet. All right. So 1 gram is equal to 1,000 milligrams. I'm going to give you that. All right. That's one of your conversions. So I'm going to pause and let you try to solve this one. Okay. All right. So I gave you the conversion, but I won't be there to give it to you during your exam. You got to memorize these. Okay. So I got to find the order. What did the doctor order? He ordered 0.8 grams of whatever drug. So I'm going to start with that, put it over 1. Numerator, denominator. Love it. What am I solving for? How many capsules? I just need to know what am I going to give my patient. I'm not going to, I already know what the strength is. I know I'm giving 0.8 grams, but I need to know how many pills that represents, or tablets, or capsules, or liquids, or ounces. So in this question, how many capsules will I give? Well, I know it's 0.8 grams. That's the strength. Pharmacy delivers a bottle and it's in milligrams. So I need to know my conversion. So to get rid of grams, I got to use my conversion. So I put the 1 gram down here and 1,000 milligrams here. Cross off my grams. And now I have milligrams. How do I get rid of milligrams and get to capsules? I got to get rid of milligrams. I'm going to use what's in my problem. 500 milligrams for every 1 capsule. So that means this 1 capsule that pharmacy delivered has 500 milligrams in it. Beautiful. Cross off my milligrams. And now the only thing left is capsules. So now it's just math. So when I multiply 1 times 500, it's 500. And 0.8 times 1,000 is 800. And when I divide 800 by 500, my calculator will tell me 1.6. What did I say about capsules? It's got to be a whole number. So is this 5 and up? It is. So if it's 5 and up, I round this number up. The answer is 2 capsules or 2 caps. All right. Please don't write the wrong unit of measure. Please, 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 please. Please. I have to move on to another type of one factor. And like I said, there's tons of practice sheets in that link I gave you. Tons. All right. So here's something called reconstitute, or no, this is just the same thing. And this one we'll do together. What is prescribed? 800 micrograms of a drug. I'm going to start there. And what is my wanted? They want to know how many milliliters I'm going to administer to my patient. So I'm solving for milliliters. So this is my given. This is my wanted. So how am I going to get there? Well, pharmacy delivers this vial. And on the vial, it says there's 1.5 milligrams for every 2 milliliters in this vial. So that's my conversion. I've got to use this. This is what's available to me. But what's the issue? It's not really an issue, but what's the challenge? This is in milligrams, and the doctor ordered micrograms. So I need to know what? 1 milligram is equal to 1,000 micrograms. Okay. So I've got 2 things I need to use in this problem. 3 things if you think about the order. So I have the doctor's order, and I need to get rid of micrograms because I need milliliters. So I'm going to use my conversion. 1 milligram is equal to 1,000 micrograms. Cross off my micrograms. How do I get rid of milligrams? I'm going to use what's available. 1.5 milligrams in 2 milliliters. Cross off my milligrams. What's left? So now it's just math. So 1,000 times 1.5 is 1,500 on the bottom, and then 800 times 2 equals 1,600 on the top. So now 1,600 divided by the 1,500, my calculator will say 1.066666. It just keeps going. So how many milliliters am I going to give my patient? What would you write on the answer line? Tahila got it. Faye got it. Milka got it. Yes. Any number between 1 and 10, I round to the tenths. I look to the right. It is 5 and up, so I'm moving this number up. So the answer is I'm going to give my patient 1.1 milliliters and maybe inject it into their ventral gluteal. I don't know. But the answer is 1.1 milliliters. Look at that. Let's do it. Let me give you a different one. No, I'll let you do this one. Go ahead and solve for this one. Nope. Let's keep doing this to me. All right. So yeah, let's do it. All right. I find the doctor's order first. What does the doctor want? He ordered 25 milligrams. Okay. Put it over 1. What am I going to give? Well, I'm going to give milliliters because it comes in a liquid. So how many milliliters am I going to give? Okay, got it. So now how do I get rid of milligrams and get to milliliters? And then I realize when pharmacy delivers the medication, it's 1,500 micrograms in 2 milliliters. So I need to know milligrams to micrograms. 1 milligram is 1,000 micrograms. So I'm going to be using this and these things in my conversions. So I start with getting rid of the units of measure I don't need. So 1 milligram is 1,000 micrograms. Beautiful. Get rid of milligrams. Now, how do I get rid of micrograms? I'm going to use what's available. So 1,500 micrograms in 2 milliliters. Gets rid of my micrograms. And look at that. The only thing left is my milliliters, and that's all that I need. Perfect. So now it's just math. So now you notice the math is getting bigger and bigger. The numbers are getting bigger and bigger, all right? So 25 times 1,000 times 2 is 50,000. And 1,500 times 1 is 1,500. When I divide, my calculator should give me 33.333, I think it is. 33333, yes. It'll keep going. So what is my answer? Well, any number greater than 10, I round to the whole number. I look to the right. It's not 5 and up. I'm leaving it where it's at. So I'm going to administer 33 milliliters to my patient. So maybe it's a cup of Mylanta that needs to be 33 milliliters. I don't know. I'm throwing it out there. But the correct answer, what am I going to administer to my patient? I'm going to administer 33 milliliters, and that will be equivalent to the strength the doctor ordered. So on the answer line, I'm going to write 33 milliliters. Beautiful. All right. So now you've already been exposed to pretty much feedings, insulins, intake and output, tablets, capsules, one factor with milliliters. When I say one factor, it means there's one part of the order. And now I want to talk about something called reconstitution. And all that means is if there's a medication that's delivered that comes in a vial that's in powder form, and we have to administer it to the patient, we can't administer the powder. We have to make it a liquid. So pediatrics, patients, infants or children that get antibiotics, before pharmacy gives it to you, it's actually in a powdered form, and they mix it with liquid so you can administer it to the child. So some of the intravenous medications that we give our patients come in a powdered form in a vial. So the nurse has to make it a liquid, and that's called reconstitution. So it's not complicated. We're either going to reconstitute these medications with sterile water or sterile saline. It just depends on what the drug reference book or pharmacist tells us how to mix it. So what does that mean for you? What does that type of problem look like? Well, this is what it looks like. So it's saying a medication is supplied as 125,000 units of a powder. The label says we have to reconstitute, meaning mix it with 10 milliliters of a diluent. The diluent is either water or saline, and that's not important right now in the problem. I just need you to know that the powder equals 125,000 units, and to make it a liquid, I have to add 10 milliliters. So what does that mean when I do that? That means I've just created a concentration of 125,000 units in 10 milliliters. That's all I've done. So what did the doctor order? He said, give 60,000 units. So I have to figure out how many milliliters I'm going to take out of this that I just made that gives me 60,000 units. We still do it the same way. I start with the doctor's order. 60,000 units. And you notice I write the units underneath it because I've seen people mistake the U for units as a 0 and get the question wrong. So I always make sure I write my unit of measure underneath. So 60,000 units is the doctor's order. Perfect. I'm solving for what? Milliliters. Perfect. How do I get rid of units? Well, I just made a concentration. That's how I get rid of it. I created 125,000 units in 10 milliliters. I cross off my units and I'm left with milliliters. That's all this problem takes. Okay. So now, if your calculator doesn't support all these zeros, and some of them, when you use all these zeros, it might come up as E. That means there's too many numbers for your calculator to hold. So what you can do is cross off the same amount of zeros on the top and the bottom, numerator, denominator. So let me show you what that looks like. If I have 1, 2, 3, 1, 2, 3, that will make my number smaller. So I crossed off 3 zeros in the numerator, 3 zeros in the denominator. That's all you have to do. The same amount in the numerator and the denominator. So now 125 times 1 is 125. Now 60 times 10 is 600, right? I got to double check my math. Right. So 600 divided by 125 equals, your calculator should say 4.8. So 4.8, let's think about it. Does that follow the rounding rules? Absolutely. So how many milliliters of the medication will you give your patient? 4.8 milliliters. So basically, when you've made this brand new vial of liquid, you change the powder to a liquid, and you made this concentration, if you pull out 4.8 milliliters from that 10, you're giving exactly what the doctor ordered in the strength. And that's how we do reconstitution, simply that. So I'm going to let you do this one. I'm going to pause the recording. All right. Excuse me. So prepare 1 million units for injection. So that's our order. 1 million units. How do we write 1 million units? You think it would be easy, right? It is. 1 million. 1 million units. And there are medications that high, and it's usually antibiotics, penicillin. So they come in this powdered vial, and the units are millions. So 1 million units is the doctor order. You receive the vial from pharmacy, and it's a powder. And it says there's 2.1 million units in this vial of powder. And you have to add in 8 milliliters of normal saline. So when we do that, you're creating a concentration, 2.1 million units in 8 milliliters. But it's shocking how so many people don't know how to write out 2.1 million. So the concentration you're making is 2.1 million units per 8 milliliters. So it says, how many milliliters will you give your patient? So I'm solving for milliliters. So how do I get rid of the word units and get to milliliters? I use the concentration I just created. So 2.1 million is written as 2.1 million. And you added 8 milliliters to the powder. So you created this concentration that you use in your problem. So here we can cross off the units, and now we have milliliters, just what we need. So now it's math. Again, there might be too many zeros, so you can cross off the zeros, being very careful to cross off equal amounts from the top and the bottom. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So 10 times 8 is 80, and 21 times 1 is 21. 80 divided by 21 is, on your calculator, 3.80952. Okay. What's the rounding rule, Spade? Come on. We didn't get the perfect number this time, did we? So any number between 1 and 10, and 3 is between 1 and 10, we round to the tenths. So I look to the right. It's not 5 and up, so my answer will be 3.8 milliliters. And when I draw up 3.8 milliliters, that will in fact only have 1 million units of strength. And that is all reconstitution is. It's just you mixing the med and you're creating the concentration. Okay, so I wanted to review that. You might see one of these on the exam. Yeah, you might. So real quick, I wanted to review how to write 1.3 million. It's 1.3 million, like that. So don't get confused, because I see people using 1.3 in 5 milliliters. You're never going to get the answer right. You have to write the whole thing out, okay? The whole thing out. All right. So that's for constitution. So if I was a betting person, you'd probably see a feeding question, an insulin question, definitely an intake and output question, tablets, maybe a capsule, definitely liquid. How many milliliters will you give? I would say definitely a reconstitution. And then how much did the patient receive in a day when you did how many? They got 4 injections. I mean, you covered pretty much a good amount so far. So these are all things to expect to be prepared to answer. Now, I'm going to move into something called 2-factor, and this is where we use IVs, IV pumps, and IV fluids. So let me just pull that up. Give me 1 second. Oh, wait, that's not the right one. Okay. So you're going to come across IV pumps, IV fluids, and there's 2 ways that we give IV meds, the 2 methods of delivery, I should say. Depending on where you work is how you will be able to deliver the medications. So, for example, if you work in a hospital, an acute care setting, you will probably always have IV pumps. These are little computers that we use to deliver IV fluids like this, IV fluids, or IV medications. And we use a special tubing. And this tubing is threaded through the machine. You puncture the bag with the tubing, and then that tubing is threaded in through the machine. And then it goes to the little patient waiting in bed for you to take care of them. Yay, thank you for saving me. And when you use these machines, the fluid is delivered in milliliters per hour. So remember that intake and output question I showed you where it said the patient was getting 100 milliliters every hour, and you had to figure out how much they received in 12 hours. And it's basically in 12 hours, if they were getting 100 milliliters every hour, they got a total of 1,200 milliliters of IV fluids. So if we have this computer, the nurse will use and select the proper fluids, the proper tubing, and put it through the machine, and they would deliver it in milliliters per hour. Okay? But not all facilities have these very, very expensive pumps. These are libraries, these are computers. So we go to a facility called Pine Valley, and they don't use IV pumps. They use something called drop factor or drip rates. And basically these are tubings. Now they would puncture the bag, and this has a dial on it, and this dial will determine how many drops per minute they will deliver to the patient. So if you are using something without an IV pump, without a computer, you are giving it drops per minute. Okay? Very important to know the difference. And we'll talk about it in a minute. Also, you have to be mindful when you look at these IV tubings, there's little numbers you'll see right here. This one says 15, and this one says 10. 15 and 10. What this means is this special tubing right here will deliver, it takes 15 drops to make a milliliter. So every time if you use this special tubing, every 15 drops makes up 1 milliliter of liquid. And this one, every 10 drops makes up 1 milliliter of liquid. And these are called drop factors. DF is drop factor. Okay. Now, I'm sure your minds are melting, your brain cells are exploding inside your head. Okay, I get it. But you can watch this over and over. You can go to the other videos, watch that over and over. Go to the PowerPoints, watch that over and over. But let's do a couple of them together. I don't know why this keeps flipping out. So here's something I want you to always remember when you're doing these questions. The doctor orders 1,000 milliliters of half normal saline to infuse over 6 hours via a pump. Okay. What is the infusion rate or the flow rate? So this is what I want you to remember. Number one, read the question. And if it's asking you anything about rate, if you see the word rate in the question anywhere, you have to decide and figure out, are you going to do milliliters an hour? If you see the word rate, milliliters an hour, or drops per minute. Now, reading this question, knowing what I just said, what do you think we're solving for? Milliliters an hour or drops per minute? All right. Why do you say milliliters an hour? What's the magic word? Pump. That's the magic word. It's saying you have a pump. If you've got the pump, you are doing milliliters an hour when it's asking you the rate. So I see that it wants rate. So I know I have a pump. It's milliliters an hour. I have the pump. So I'm solving for milliliters an hour. Now look how I wrote it. Milliliters in the numerator, hour in the denominator. Now we're moving into two-factor. So the doctor wants to give 1,000 milliliters over 6 hours. Numerator, denominator, volume over time. I'm solving for volume over time. So how many milliliters an hour am I going to put into that pump? And you're following the rounding rules, Justin. PL, you got it? Kirby got it. Justin, what'd you get? Yes, IV pumps can use decimals. Yes, they can. It is 167 milliliters an hour. You got it. Yeah, absolutely. So 166.666 is greater than 10, right? So when you divide, you already have milliliter here and hour here. You don't need any conversions. You just need to divide 6 into 1,000. And on your calculator, it'll give you 166.666. What are my rounding rules? Any number greater than 10, that's greater than 10. I look to the right because I'm rounding it to the whole number. So my answer is 167 milliliters an hour, and that's how you should write it. Okay? Because, Justin, great question though, by the way. What if you're given a cardiac med or a blood thinner and you have to give precise dose? You can give 5.5 milliliters an hour, or if you're giving insulin, 10 point, that's probably not a good example, 9.6 milliliters an hour. So yes, these computers can do decimals. So why don't you do this one? I'm going to record what I just said to you. Yeah, great question. What's the difference between infusion rate and flow rate? There's no difference. I just want you to be able to identify that if it says rate, whether it's infusion rate, flow rate, drip rate, drop rate, you have to make a decision. Is it milliliters an hour or drops per minute? And it just determines how fast you're going to give that intravenous liquid. So what is the answer to this question? Okay. So I've added a little conversion. The doctor says give 1 liter over 8 hours. And we're solving for an infusion rate. And I have a pump. So when I was learning this, I would write the word rate. They want to know the rate. So I have to decide, am I doing milliliters an hour or drops per minute? I have a pump. So it's milliliters an hour. Beautiful. So I have to give 1 liter. 1 liter over 8 hours. So I have hour, but I have liter. How do I get to milliliter? 1 liter is 1,000 milliliters. Look at that dimensional analysis in action. Oh, God. So 1,000 over 8, and that will be 125 milliliters an hour. That's it. And certainly, if you knew right away that 1 liter is 1,000 milliliters, you don't have to start with 1 liter. You can just go 100 milliliters over 8 hours. And if it's nothing, you can just divide. That's milliliters an hour, and then you can solve. It equals 1,000 over 8, and there's 125 milliliters an hour. Okay. So I'm going to give you this one more to do, but I added the drop factor here for a reason. DF 10. That means drop factor 10, which means 10 drops per milliliter. So do I need to use that if I'm using the IV pump? Well, the answer is no. And the reason we put it in the questions is because your tubing says it no matter what you're using. So you have to know when you need it, when you don't need it. So the doctor wants to give 1.5 liters of D5W over 12 hours. So 1.5 liters is actually 1,500 milliliters. I have an IV pump and they want to know the rate. So I'm either doing milliliters an hour or drops per minute, right? If I have the pump, it's milliliters an hour. So I don't need the drop factor if I have the pump. And I have milliliters and I have hours. So it's literally 1,500 divided by 12. And yes, it is 125 milliliters an hour. And that's how you do IV pump questions. It's just making sure you're not getting confused, which some of you will. It's okay. That's why we're here to learn, okay? This question has additional information. The doctor orders 1,000 milliliters of D5W that happens to have potassium in it. And he wants you to run that over 12 hours. What is the infusion rate or the flow rate? What am I solving for in this question? It says rate, and I have to make a decision, milliliters an hour or drops per minute. So yeah, you would think, oh wait, you got to figure out for drops per minute. But this is why I put this in here. We can't do drops per minute without what? A drop factor. And that's what we're going to do in the next slide. So I have to make an assumption here that I have a pump because I don't have anywhere in this question a drop factor. It doesn't tell me what type of tube. So I have to solve for milliliters an hour. So if I'm solving for milliliters an hour, what is my starting point here? What am I putting in the numerator? If I need milliliters in the numerator, I'm going to put volume right on. And what am I putting in the denominator? Time. That gives me everything I need. Don't get fooled by trying to add this. That's a medication strength. It didn't ask you strength, it asked you infusion rate. When it says rate, you're only solving for these things. Don't get confused. It didn't say how many milliequivalents of potassium, okay? Volume over time. So when you do it like this, 1,000 times, sorry, 1,000 divided by 12, it will give you 83.33, which you will round to 83 milliliters an hour, okay? This one, what do you think the answer to this one is? Just look at it real quick. What is it asking? Rate. I got a pump. Right. But I also have a drop factor. I don't need it because I've got this magic pump. Disregard, yes. Excommunicado. 500 milliliters in 1 hour. So what's my infusion rate? PL got it. 500 milliliters over 1 hour. My answer will be 500 milliliters an hour. So this patient is sick, very sick. Good. All right. Let's go to drop factor. All right. So this is when we don't have a pump. What is the flow rate, drop rate, infusion rate? If it says the word rate, always do the same steps. I have to make a decision. Either it's milliliters an hour or drops per minute. And in this question, I don't have a pump. But what do I have? I have a drop factor. So I am absolutely solving for drops per minute. You see how I write it? Drops in the numerator, minutes in the denominator. So I know what I'm solving for. So what is the doctor ordering? 500 milliliters volume over 4 hours, volume over time. And now I have a drop factor to deal with. So now I am nowhere near drops per minute. So how do you think I can get rid of hours and get to minute? What conversion could I use? Yeah. Every 1 hour has 60 minutes. What? So I have minutes. Now, how do you think I get rid of milliliter and get to drops? Going to use that drop factor. There's 20 drops for every 1 milliliter. Crosses off my milliliters. And now I have drops. What? Professor K's a magician. I got rid of everything I don't need, and now I have everything I do need. Drops over minute. Drops over minute. So now it's just math. So 500 times 20 is 10,000. And 4 times 60 is 240. And 10,000 divided by 240 is 41.6666. So, do you think we can split a drop when it's dripping down in the chamber with no pump? The answer is no. So when we talk about drops, we're literally talking about drops in a chamber, punctured into a bag. There's no way we can split that drop. So the one thing you have to remember about drops per minute is always a whole number. So the answer is we're going to run this at 42 drops per minute. Okay. Go ahead and solve this one. All right. All right. Sorry, but the other question I put up was the same question. So yes, I'll show you how we can cross this off because you have to know what the drop factor means in order to cross off the milliliters. So a patient is to receive 200 milliliters over 4 hours. Drop factor is 10. What is the drop rate? So there's that magic word, rate. So I'm solving for the rate. I have no pump. And I have a positive drop factor. So I am solving for drops per minute. Numerator, denominator. All right. Then I look for that volume over time. Volume over time. 200 milliliters over 4 hours. But I don't have a magic pump. But I have a drop factor of 10, which means what? It takes 10 drops to make 1 milliliter. And that's how you use it in your crossing off in your dimensional analysis. So I like to start with the bottom. I just like it. Hours to minute, no problem. 1 hour is 60 minutes. Crosses off my hour. I have the denominator done. Now, how do I get rid of milliliter and get to drops? Well, the only thing I didn't use was my drop factor. because I've used this and I've used this. So to get rid of the milliliters, I'm going to put 10 drops for 1 ml. I cross off my milliliters and that leaves me with drops. So I have just drops and minutes left, numerator and denominator. So everything else is crossed off and now it's just math. So 200 times 10, 2000, 60 times 4 is 240, and divided by 240, that will give me 8.33333. Remember, in that chamber is just little drops that you can't split, right? So we can't split a drop. So the answer is what? I have to round to the whole number. This is not 5 and up, so the answer is 8 drops per minute. Boom. All right, let's do another. All right, I'm going to pause it here. I want you to think about this. That's all right. Well, if you got stumped, it's okay. Let's just keep doing the same steps. What is the drip rate? Okay, saying that magic word, rate. What is a drip rate for an IV ordered 1 liter a day with a drop factor of 8? All right, so I'm solving for rate. So I either have to do what? Milliliters an hour or drops per minute. I always do the same thing. I'm not losing any points, right? So I have no pump and I have a drop factor. So no pump, and they give me a drop factor. You got it, Deanna. Good. So that means I'm solving for drops per minute. Okay, cool. At least I know where I'm going, right? I know where I'm going. And I know where to start. I look for that order. 1 liter per day. Volume over time. So 1 liter is 1,000 milliliters. How many hours are in a day? Okay, professor, come on. Yes, that's how I'm going to use it per day, because it didn't spell it out for me. I have to critically think. I don't know how many minutes are in a day. I can figure it out, but I know there's 24 hours in a day. So volume over time. So they need 1,000 milliliters in a day, and a day is 24 hours. I know what to do with an hour. 1 hour is 60 minutes. Okay, got you. And how do I get rid of the milliliters? Well, if my drop factor is 8, that means it takes 8 drops to make a milliliter, and that's what I'm going to use. 8 drops per milliliter gets rid of my milliliter, and now I have drops per minute. Now it's just math. Now it's just math, and this is where it's just about using this dimensional analysis. So 1,000 times 8 is 8,000, and then I do 24 times 60 is 1440. When I divide, my calculator will say 5.5555. Can't split a drop in the drop chamber. So yes, Kirby, it is 6 drops per minute. And that's how you solve the gravity. All right. There's one more type that I want you to know. Micro drip. Micro drip is considered a drop factor, and it's part of what you have to memorize. If you see micro drip in your equation, that means 60 drops per minute. Micro drip means 60 drops per minute, but it's the same process. I'm solving for rate. I don't have a pump, but I have a drop factor. So I'm solving for drops per minute. Volume over time. And it's the same process. 1 hour is 60 minutes. And micro drip, 60 drops. I wrote minute, I meant milliliter. I'm so sorry. 60 drops per milliliter. And that's how we cross off all of our unwanted drops per minute. So micro drip means 60 drops per milliliter. It's a special type of tubing that they still use today, but it doesn't, I don't know why it doesn't just say 60 drops per milliliter, but it says micro drip. That means 60 drops per milliliter. It takes 60 little drops to make 1 milliliter. That's what you use in your problem to solve. So I just wanted to remind you of that. So 1,500 times 60 is 90,000. And then we have 8 times 60 And that will give you 480, and then we do 90,000 divided by 480, and that means you would calculate, nope, that ain't right. I gotta figure this one out. Yeah, it is right. It would, your calculator will give you 187.5, and you will round that to 186 drops per minute. All right, so I just wanted to point that one out. Another type of question you should be familiar with, and it doesn't matter the size, why 186? 187.5, we round, we can't split a drop.
And we shouldn't round up.
Oh, I'm sorry, oh gosh, thank you, 188, sorry, I'm looking at my own math. Yes, round up, 188, sorry about that. 188, okay. Thank you. When you look at numbers all day, every day, it starts to get a little crazy. Sometimes you're gonna have smaller volumes to deal with, but you're gonna always follow what the question is asking. If you look at this question, it's still asking you flow rate. So I'm still making a decision, milliliters an hour, drops per minute. I have no pump, and I have a drop factor, so it's drops per minute, okay? You're still, in all of these questions, you're looking for that volume over time, okay? 50 milliliters over 30 minutes. So maybe this patient is getting an antibiotic, an IV Soluset. And we have a strength in there, but I don't need the strength. It's not asking me that in the question. It's asking me how fast am I running the IV fluids. It's asking me infusion rate, flow rate. So volume over time, I'm solving for drops per minute. I have my minute. So now all I need to do is change milliliters to drops. And my drop factor is 10. So what does that mean? 10 drops per milliliter. So if you read the question and then you know where you're going, you'll be able to solve these problems. But when you don't know, because whether lack of preparation or just no understanding, then you start adding things into the question you don't even need. All right. So when we do this question, it'll be 50 times 10 divided by 30. And that, yes, Kirby, I'm just checking. Yes, good. Okay. It'll be 16.666. Which we will round to 17 drops per minute. But I just want to show you the different variations, but it's the same. Why do you disregard the 50 milligrams? In this question, it doesn't ask you to solve for the strength. It's just asking you to set the rate. It's saying that this patient is going to get this bag, which has 50 milliliters, and maybe there's 50 milligrams of Benadryl. It's just asking you to solve how fast to run it. It's not asking you to solve how many milligrams an hour they're getting, okay? Which brings me to a great question. What if you are asked to solve for milligrams an hour? How do you do it? Well, if we read this question, an IV pump is set to deliver 13 milliliters an hour. The IV solution is labeled with something, and it's telling you what they need solve for, how many milligrams an hour. So this question, we need to use the strength. So I know I'm solving for milligrams an hour. Beautiful. Where do I start? Where do I start? I would start with volume over time because time is part of my wanted. And I already have half of my question complete. I've got hours in the denominator. So now it's just a process of elimination. The only thing I haven't used is what is on the label. So let's use it. How do I get rid of milliliter? Cross off milliliter. Now, how do I get rid of gram and get to milligram? Conversion. And that's how you do dimensional analysis. You can do it for any type of problem. And I don't expect you to know it just because we've been meeting for 2.5 hours, okay? But this is the type of questions you're going to have to practice before your exam. Okay, and all of the content is there in the videos as well. You can reference back to this video, reference back to all the other videos. So the content is there. So now it's just a matter of math. So 13 times 1,000 is 13,000. And then 250 times 1 is 250. So if I were to divide that, this means the patient is getting 52 milligrams an hour. So in this question, the strength mattered because it asked you to solve for the strength. How many milligrams an hour? That was what it was asking you. In these questions, it asked you, how fast are you going to run it? So it's just telling you that's what's in there, but I need to know how fast you're going to run it. This question said, great, I know how fast you're going to run it, but what are they actually getting? And this is a very common type of question when you're practicing as a nurse. Let's say you're running this medicine at 13 milliliters an hour and they have a reaction. And the doctor's going to be like, how many milligrams have they been getting every hour? You can figure it out and say, well, he's been getting 52 milligrams an hour. Should we decrease that? Should we stop that? Is that a normal response? So that's why we alternate and do these solves on these questions. All right. Now, we've covered 1 factor, 2 factor, milligrams an hour, milliliters an hour, drops per minute, tablets, capsules, intake and output, insulin, feeding. I'm feeling good. I'm feeling confident for y'all. I really am. So let's see. The only thing I really want to cover before we finish is now something called 3-factor. I just gotta find it. Hold on 1 second. All right. No. Okay. Sorry, I'm just trying to find the one question I want. Oh man. Okay. So this here is an example of a 3-factor type of question. These are very high level questions. So remember, this is basically, you know, a big course that you guys are taking this challenge, and I love that you guys are doing this. So in here, we're looking for the doctor's order. And this one is not really the doctor's order, but it's telling you what the safe dose of a medication is. And it's got 3 elements to it. 1 is the strength, 2 is weight, and 3 is time. And then it's telling you the patient's going to get 3 divided doses, so 3 times a day. It gives you the patient weight. It tells you what the medicine is labeled as. And then it says, hey, how many milliliters are you going to give for a specific dose? So everything is in the setup of all your problems. So it wants to know how many milliliters you're going to give for the 9 a.m. dose. So I want you to write milliliters over dose. That is your wanted. This is what we want to solve for. We got to figure out of all of this information, how many milliliters am I, the nurse, going to bring to my patient who is an infant because he weighs 20 pounds. I don't want to screw this up. I got to make sure I'm right. So how many milliliters am I going to give at that 9 a.m. dose? Because he's getting 3 doses all day. He might be getting one at 9 a.m., one at 3 p.m., and one at 11 p.m. But I need to know, what am I going to give at that 9 a.m. dose? Because he's getting 3 doses all day. And a day is 24 hours, right? So I'm going to start with this 3-factor. And this is how you write a 3-factor. 0.5 milligrams, the strength in the numerator, and the weight and the time in the denominator. Now, remember earlier I said I like to get rid of all the things in the denominator first. So I'm about to show you how to do this, okay? I need to get rid of all of these units that I don't need, right? I can't have milligrams in my problem. I can't have kilogram in my problem, and I can't have day in my problem. I got to get rid of all of these units of measure. All I need is a milliliter on top and the word dose on the bottom. So how do I get rid of this word day? Well, to get rid of the word day and cross it off, I have to write the word day over here, right? So every day, how many doses is this patient supposed to get? Take a wild guess. Read the problem. 3. Every day, the patient's going to get 3 doses. Okay. Cross off day. I got dose. All right. But now I got to get rid of this little crusty kilogram right here. And I have a patient's weight in pounds. So how do I get rid of the word kilogram? I have to put it up here. So 1 kilogram equals how many pounds? 2.2 pounds. And I get rid of kilogram. But now I got pounds in my denominator. How do I get rid of the pounds? The patient's weight. So you see how it's this game of elimination. And if you can gamify in your mind of eliminating everything you don't need, you're going to get to your problem. So now I'm crossing off everything I've already used. And the only thing left is my milligrams and 2 milliliters. So if you look at my problem, the only thing in my denominator is the word dose. Beautiful. But now I just need milliliter in my numerator, and I have this milligram sitting here. So how do I get rid of that milligram? What can I use? What about this? 1 milligram in 2 mLs, correct. When I do that, I cross off milligram, and look at that. All that's left is milliliter and dose. Everything is crossed off. And now it's just math. It's gross math. It's really gross, but it's doable math. So basically, I'm just going to go across top. 0.5 times 20 times 2 is 20. And on the bottom, 3 times 2.2 times 1 is 6.6. So 20 divided by 6 is 3.0303. So how many milliliters am I going to administer for the 9 p.m. dose to this 20-pound baby? Sorry, I don't know why this keeps. How many milliliters? And how would I write it? Faye, you got it? Vilka got it? Yes, you would write it as 3 milliliters. Do not write it as 3.0 milliliters. We don't want to mistake it for 30 and kill a 20-pound baby with an overdose. 3 milliliters per dose. That is it. This is one of the highest level questions you'll come across. It's either starting with a 3-factor or ending with a 3-factor. Okay, so this is as challenging as it's going to get with these. Let's see. Here's the other type you may see. We're gonna just do this together because you really just have to practice this stuff. All right. An IV medication is labeled 250 milligrams in 250 milliliters of D5W. It's running at 35 milliliters an hour through a pump. How many micrograms per kilogram per minute is a 165-pound patient getting? So what am I solving for? That's micrograms per kilogram per minute. Woo! This is a tough one. I know where I'm going. So where do I start? Well, I need time. So I look for volume over time. And now it's just a process of elimination. How do I get hour to minute? 1 hour is 60 minutes. Beautiful. I got minutes. How do I get kilogram in here? This is where we do nurse math. We just add it. 1 kilogram is 2.2 pounds. I do what I want. I'm a nurse. There's kilogram. Boom. So my denominator's good. Now, how do I get rid of all this on the top? Just a matter where you want to start. How do I get rid of milliliters? Well, I haven't used the concentration. Got rid of milliliters. How do I get rid of pounds? I haven't used the patient weight. And yeah, I just write it on the bottom. I do nurse math. Put a 1 on top, cross it off. Now, how do I get milligrams to micrograms? 1 milligram is 1,000 micrograms. What? Now you can see how these type of problems get crazy. So what kind of math are we doing here? A lot. So we got 35 times 2.2 times 250 times 1,000. But what if your calculator can't answer it? I mean, it's my calculator does. It's actually 19,250,000. But you can cross off zeros. You can cross off like numbers, top and bottom, 250. You can cross off zeros if you choose to. But either way, however you choose to do it, I'm not here to teach you how to do math, just the calculation. But there are ways to get it to work out. So 60 times 1 times 250 times 165. That'll give you 2,475,000. And then when I divide, yeah, we're talking high level. I'm trying to do the math here. It will be what? Does anybody know? It'll come out to 7.77. We're using a pump, so we can use our decimal rounding. So it's less than 1. I mean, it's between 1 and 10. I'm sorry, I'm getting tired now. So 7 is 5 and up. So the answer will be 7.8 micrograms per kilogram per minute. This is high level cardiac critical care medications right here. So you see how the setups are everything. All right, hold on 1 second. I want to show you one more thing. Trying to find it. All right. So the recommended dose for medication is 10 milligrams per kilogram per day. How many milligrams will the 105-pound patient receive for the day? So I'm solving for milligrams per day. Milligrams per day. My 3-factor, 10 milligrams per kilogram per day. So I have day. So I have to get rid of kilogram. My patient's weight is in pounds, so 1 kilogram is 2.2 pounds. And my patient weighs 105 pounds. See how it's a process of elimination, as I've said. So now I have day and I have milligram. So now it's just math. So 10 times 105 is 1050. And then 2.2 times 1 is 2.2. So the patient is receiving, your calculator will say 477.27. So it's a whole number. So we look to the right. It is not 5 and up. So we're going to say the patient will get 477 milligrams a day. And that's that's the basic, simple 3-factor strength, weight, time. Process of elimination. If you know where you're going and where you're starting, just eliminate, eliminate, eliminate. Okay. Let's see. The last thing I want to show you is solving for time. All right. So again, we reviewed feeding, insulin, intake and output, tablets, capsules, reconstitution, total dose in a day. That would be the one where the patient maybe got 4 milligrams times 4 injections. What's the total dose they got? So we've got feeding, insulin, intake and output, tablets, capsules, concentrations with liquid, reconstitution, total dose in a day. So 5, 10, 15, 20, 25, 30, 35, 40. IV pump, IV gravity, milligrams an hour, 3-factor IV, when we start with a 3-factor or answer for a 3-factor. And now we did 3-factor medication. So this one is what's left in the bag, as we call it. LIB means left in the bag. So this one is what time will the IV finish? So we're solving for time, which is hours over 1. We got to solve for time. Okay. So an IV of 1,000 milliliters was hung. So they started the shift and perhaps they hung this big bag of 1,000 milliliters of sugar water, D5W. And it's been going at 45 drops per minute, all shift. You walk in at 1,300 for your shift. And when you go in the room, there's only 400 milliliters left in the bag of this liquid. There's only 400 milliliters left. What time will that 400 milliliters finish? What time will that bag go empty? You need to know the time it will go empty, so you will bring a brand new bag in and hang it. We don't want the bag to go dry. So you need to know what time to go back in. So we always start with what's left in the bag. You walked in the room and there was only 400 milliliters in the bag. What time are you going back in? All right, well, let's figure this out. So I don't care about this. That's nice. They started with 1,000, but I came in at 1 p.m., 1,300. I need to know when this 400 milliliters is going to be empty. So I start with 400 milliliters. Now, I just got to eliminate 400 milliliters and get to hours. So what am I going to do? How am I going to do that? Well, it's running at 45 drops per minute, and the drop factor is 8. That means what? 8 drops per milliliter. So that's what I'm going to use to get rid of milliliter. 8 drops per milliliter. Cross off my milliliter. Now, how do I get rid of drops? I'm going to use the rate it's going at. It's been running at 45 drops per minute. Okay. Cross off my drops. Now, how do I change minute to hour? There are 60 minutes in 1 hour. Now it's math. So I do 400 times 8, and that's 3,200. And 45 times 60 is 2,700. It will give me an answer of 1.1851851. So something you need to understand is any number in this equation, any number before the decimal represents hours. This is 1 hour. And anything after the decimal represents minutes. But there's no such thing as 0.1851851 minutes. So I have to convert this to minutes. So in my calculator, I'm going to type in 0.1851851 times 60. And it should give me 11.111111. And then I'm going to round that to 11 minutes. 1 hour and 11 minutes. This 400 milliliters will take 1 hour and 11 minutes to infuse. What time am I going back in the room though? It's asking me what time. If I walked in at 1300, think about it. I walked in at 1300 and it's going to take 1 hour and 11 minutes to run. What time do I go back in the room? You don't have to do the seconds. 1411. And that's how you use military time, not point four. Don't do 14.11. Military time has no decimals unless we're using seconds. So military time, 1411 is what time? The answer is 1411. But what does that represent? Yeah, 2:11 p.m. 1411 means 2:11 p.m. So that's how you solve for time. All right. Now I know we have ingested a whole lot of content, a whole lot, but it is doable. So I want to share when you go into those when you go into the practice sheets, really look for oh, maybe I'll send you guys a separate email. I'll add some of these things to the separate email. Some of the things I'll send you, just keep practicing over and over again. It's really that muscle memory, but you do have to start memorizing the conversions because you won't have that information available to you. All right, but you do have a good amount of weeks to prepare that I think it's so possible. I have a lot of people that pass this when they take the challenge exam. And if they don't, they don't, whatever. It is what it is. You just come and hang out in class with me or you do it online. All right. But certainly practice will make you prepared. Okay. Now, are there any other questions? I know it was a lot of information. Anybody need a hug? What do you need? Are you okay?
I need a hug.
You do. I know. I hear you. Me too. Me too. My dogs are like, I gotta go out, man. Are you done?
This is a lot of information.
They're probably like, who are you talking to? It is a lot of information. We just crammed like 14 weeks in 3 hours, you know? Is there anything else that wasn't covered today that might be on the exam? I think we covered everything that you should expect. Or some variation of it. Definitely go through the PowerPoints. Definitely do the practice questions. And just go look at those other videos. They really will help you prepare. Okay. If you're able to commit to that, I think you'll do all right, as long as you stay out of your own head, which is the hardest thing for nursing students. All right. If you have any questions, feel free to email me. If I don't get back to you right away, I will, you can send me another reminder email because I'm not really on. I'm off for the summer, but certainly just email me. I will re-email that link and some of the forms. How many questions? 20 questions are on the exam. You get 1 hour to finish the exam. There are 5 points.
Would the YouTube video be available today for us,
Just click the
or?
link. You can. Oh, this one? Yeah.
Yes.
At the mercy of when they. Literally, I have to wait for Zoom to send me the recording.
Oh,
As
okay.
soon as I get it, I'll post it.
Okay.
And it'll say today's date. You'll know which one it is.
Okay. Thank you.
Sure. All right. You guys have a great weekend, and thank you for hanging out with me.
You as well.
Thank you. You do as well.
Thank you.
Thank you.